The standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a is not allowed to be 0, because if it were, then it would no longer be a quadratic function. So a, b, and c represent the coefficients of the function. Okay, so if I gave you this quadratic function and I asked for you to identify the values of a, b, and c, the first thing you would have to do is put it into standard form. So you would have to FOIL this. So the first step would be to multiply 2x times x, and you'd get 2x squared. Then then 2x times negative 2, and you get negative 4x. Negative 5 times x and get minus 5x. Then you get negative 5 times negative 2 and get plus 10. Now, notice that our two middle terms are like terms, so our final answer, we have to add those together. So we can say that 2 is our value for A, negative 9 is our value for B, and 10 is the value for C. In our second example, we're going to have to do the same exact thing. So we're going to FOIL. 4x times x gives you 4x squared. 4x times negative 6 is minus 24x. 3 times x is 3x. And 3 times negative 6 is minus 18. Again, the two middle terms are like terms. That's what we call our linear terms since they're with x. And so our final quadratic is 4x squared minus 21x minus 18. Okay, so let's recall that we know that we call a quadratic a parabola. So it's either it's a U shape that is either facing up or facing down. Now, there's something else that's called the axis of symmetry. The axis of symmetry is a line that's going to cut this quadratic in half. So on this yellow line, if I were to fold it over this line, both sides would map onto each other. Now, the axis of symmetry always cuts through the vertex. So here, the vertex is the lowest point, which is the minimum. Or if this was an upside down parabola, or opening down parabola, it would be the highest point, which would be the maximum. So here we have the vertex as the point 1, negative 4. And when I ask for the axis of symmetry, you give it to me as an equation. So it cuts through the x-axis, so it starts x equals, and it goes through positive 1. So x equals positive 1 is the equation to this yellow line. I always also say that this is the vertex, so it's the axis of symmetry is the x in the vertex. Notice that our x value is 1. All right, another feature of the graph are going to be our x-intercepts. These are also called zeros. They could be called zeros, they could be called roots, and they also just could be called the solutions. And we're going to get onto that and why you can call it many different things a little bit later. So, where it crosses the x-axis, we have our x-intercepts. We also need to identify where it crosses the y-axis, and this point is 0, negative 4, and since it's the y-intercept, 0 is always going to be our first, 0 is always going to be our x value. It's important to know that our domain and range, our domain is going to be all real numbers for every single quadratic because it goes left and right forever, whether it opens up or down. Now, our range depends on that min or that max value. So let's just say for this sake, the lowest value is -4 because it's the y value in my vertex. So I go from -4 and it touches it, like that point down here on the vertex touches at -4. So it's a bracket. And since it opens up, it goes to positive infinity. So if you were trying to find the value of the vertex, that min or that max, it's important to know how to do that in the calculator. So after you plug in your quadratic into y1 equals, you then want to go to second and then the trace button. And these details and descriptions are on the back of your worksheet that you're working on. So if you go to second trace, you then want to choose either option 3 or 4, 3 being minimum, 4 being maximum. So depending on, when you hit graph, look at it, and if you have a minimum, then you need to choose that one, and if you have a maximum, you choose that one. It's going to say left bound and right bound, so all it wants you to do is go to the left of the point that you're trying to find and hit enter, and then go to the right and hit enter, because what that does is it creates this boundary line. So in between, you're pretty much telling the calculator, in between these two lines that I set as my bounds, there is a minimum. Find it. So it will do that for you. So you can actually tell if the parabola will have a minimum or maximum based on if it opens up or down just by looking at the equation. And it all depends on this a value. So if a is positive, meaning it's greater than 0, then the parabola is going to open up. Now, when it opens up, it looks like a U shape. So therefore, we have a minimum. Then, if a is less than 0, so it's a negative number, then it's going to open down. Meaning we have a maximum. So all of these characteristics of a quadratic is what you need to do on the back of that worksheet. You need to graph all 3 of them, identify your A, B, and C, domain and range, whether it opens up or down, vertex, your axis of symmetry, which must be an equation, so x equals, and then whatever number, and then find your y and your x intercepts. So work with your calculator, plot all your points, don't just sketch a graph, actually plot points and connect them. And then answer the questions on the back of the worksheet. It doesn't matter, you don't necessarily have to go in order because you'll notice that some questions help you answer some other questions.